Okay, so this is a word problem in standard form and is a problem that you'll see throughout this unit. So the problem states that the length and the width of a rectangle are 6 centimeters by 4 centimeters. When each of the dimensions are increased by the same amount, the area of the new rectangle is 50 meters squared. Find the dimensions of the new rectangle to the nearest length of a meter. So demonstrating a whenever it's demonstrating or giving you dimensions, you always want to have a diagram, which is why I have a diagram. So it's a simple diagram, just any rectangle that's 6 centimeters by 4 centimeters. The rest of the problem states that when each of the dimensions are increased by the same amount, the area of the new rectangle is 50 meters squared. So now we can draw ourselves a second rectangle just for visual reference. This is completely optional. If you just prefer one, that's completely up to you. So 6 centimeters, which is the length, is increased by x. 4 centimeters is increased by x again. And x is our variable because they're both increased by the same amount, and it's common sense in a word problem or any sort of problem in math. You usually have to find an x, so you always need a variable, so one side always needs to be x. So now for our equation and for some algebra. Okay, so we know our equation or formula for area is length times width. And the area is already given to us in the problem, which is 50 meters squared. So our length, which is 6 centimeters, the formula for this will be 6 plus x. And for the width, which is 4, it will be 4 plus x. So put it all together and we get 50 equals 6 plus x and 4 plus x. Now you've probably seen this form in many other areas of the unit, and now we should know that we need to expand and simplify this part of the equation to get it into standard form so we can get the a, b, and c value in order to find the x value. Now I'm just going to solve this equation and we'll be right back. So here is the equation solved. So I didn't show all my steps, but I'll just review it. So when we have the formula in this form, we know that we have to expand and simplify this binomial in order to get our standard form. So we get 24 plus 6x plus 4x plus x squared. And you know that once you use FOIL, you should have two middle terms, which you either subtract or add for you to get a trinomial at the end. So then I got 50 equals x squared plus 10x plus 24. So x squared was just moved to the front. 6 plus 4, 10, 24 would stay the same. So then remember, whenever we have an equation in standard form, in order to find our x-intercepts, one side must always be 0. So 50 gets brought over to this side, and you know that when a number is brought over to the other side of the equal sign, it becomes the opposite of what it was before. In this case, 50 was a positive number, so when it was brought over to the other side, it becomes a negative. So 24 minus 50 would equal negative 26. So our equation is 0 equals x squared plus 10x minus 26. So from this equation, we have our a, b, and c value. A equals 1, since there's nothing in front of the x term. B equals 10. C equals negative 26. Make sure you guys remember to have your integers in place, because if you guys forget the negative, then it's going to impact your whole solution at the end. So now that we have our a, b, and c value, we can use our quadratic formula, which is nicely written over here, to figure out our x-intercepts. So I'm just going to solve this equation and I'll be back to explain how I did it. Okay, so we stopped at having our formula in standard form. Now we have our a, b, and c value, and now we can use the quadratic formula to basically find our x-intercept. So it's pretty obvious. So you have your a, b, and c. Quadratic formula is all about subbing in your numbers and making sure you have the integers rightly in place. So over here, you can see that these two numbers are negative. So your answer over here should be positive, not negative. If you guys did 100 minus 104, that would give you the wrong numbers, and you would not, at the end, you would not get two numbers that add up to the area 50 meters squared, which has already been given to us in the problem. So after we do our quadratic formula, of course, we get two intercepts. So now we know that we have to use 2.1 meter, not negative 12.15, because as you know, measurements cannot be negative. You cannot have negative 12.15 meter squares as our dimension. So this one cancels each other out. So now that we've got our x, we're not done yet. We have to go back and sub it into our formulas for length and width. So if you guys remember, our formula was for length was 6 plus x. So now that we know our x, we can sub it in, which is 2.1. So x plus 2.1 gives us 8.1. So now we know our length. So our new length will be 8.1 meters. So our new length would be 8.1. And our width, we do this exactly the same thing. 4 plus x, we sub in our x, which is 2.1, and we get 6.1 meters squared. So these is not squared. So these are our new lengths. In order to double check your answer, you can of course use your formula again, area equals length times width, and if you multiply these two dimensions together, you would get 50 meters squared as your total area. So the word problems in standard form are not that hard. They follow the same pattern, especially these type where it's talking about the expanding of the dimensions. Always make sure that one side always has to equal to x, and make sure you have your formula ready. The setting up part of a word problem is usually the hardest part. Once you have the problem set up, the rest is pretty easy.